AB Calculus, section 5.4, page 3. You are asked in number 6 to find the area of this shaded region. And if we notice, this shaded region is actually defined by two curves, y equals the square root of x and y equals x squared. Over here we see the size of the window, and you remember this little symbol right here means is an element of. So x is an element of the set from 0 to 4, which gives us the size here. Here's 0, 1, 2, 3, 4. Y is between 0 and 4.5. So 1, 2, 3, 4, and then this little extra bit here, clearly the half. When we look at finding the area of this shaded region, then we will need to split this up and look at the integral from 0 to 1 underneath the square root of x dx, and then we'll need to add on the integral from 1 to 2 of x squared dx. Working through this one, first thing, just like when we did derivatives, flip this to fractional exponents. And then when we'll anti-differentiate, this is x to the, add 1 to the exponent, 3/2. Take the leading coefficient here and divide by that new exponent. So 2/3. Evaluated that from 0 to 1. Gives us 2/3 of 1 to the 3/2 minus 2/3 of 0 to the 3/2. Clearly, that's 0. And 1 to the 3/2 is 1 times 2/3. This piece is just 2/3. When we look over here to handle this one, the antiderivative of x squared, add 1 to the exponent, take the coefficient out here, the original coefficient, divide by that new exponent, so 1/3, evaluated from 1 to 2, and this will give us 1/3 times a 2 cubed minus 1/3 times 1 cubed, which is 8/3 minus 1/3, or 7/3. Then putting these two together, 9/3, which is 3. And there's your answer for the area underneath that, or for the area of that shaded region. All right, I do want to comment over on the side over here how to handle these fractional exponents. I think you are fine with a 1 to the 3/2. But what happens if we have something like 4 to the 3/2? All right, think about this as this numerator in this fractional exponent is the power, and 2 here is the root. It's generally easier to do the root part first. So if we handle this as the square root of 4, then cubed, that gives us 2 cubed, which is 8. Another option, which is perfectly acceptable, is to handle the power first. So do 4 cubed, and then do the square root of that. 4 cubed is 64. Square root 64 is 8. It makes no difference which route you go. Generally, doing the root part first is easier because the numbers are smaller. But make sure you can handle something like this 4 to the 3/2 or 9 to the 3/2, something like that. All right, going back to this problem, what if we want this shaded region? Notice the window has changed slightly. The x window is exactly the same, but the y is shrunk down to, so topping out here at 4. And to find this area, we can simply drop a vertical right here at this ending point, at that point 2,4, and then look at the area of the rectangle minus area under the curves. Area of that rectangle, 2 wide times 4 high. 4 high, no, 4 high. That's 8 minus area under the curves from up above, 3. And 8 minus 3 is 5. there we go.